this video, we'll focus on absolute value inequalities involving greater than or greater than or equal to. So here first, let's look at the simplified inequality. Absolute value of x is greater than or equal to 5. So this is similar to what we saw last time, but now we're looking at greater than or equal to instead of less than. So if I want the absolute value of x to be greater than 5, that means I want the distance that x is from 0 to be more than 5 units away from 0. So if I'm thinking about the values that are 5 units away, I'm looking at 5 and -5. That's exactly 5 units away. Since we're equal to here, we can include those numbers, but I also want to be farther from 0 than 5 units. So I would shade the values that are to the right of +5 because that gets me farther and farther from 0. And then I would shade the values that are to the left of -5 because that gets me farther and farther away from 0. So now I have two pieces of my number line shaded, and these two pieces are not overlapping. This is an OR inequality. So down below here, you have that OR inequality written out. So looking at the piece on the left-hand side here, this means that x is less than or equal to -5, less than or equal to -5, or on this side, x is greater than or equal to +5. So I could use this graph to write my compound inequality. Now, if I had a simply greater than symbol, not greater than or equal to, the only thing that would change would be whether or not I include -5 and +5. So if this did not have the equal to, I would have parentheses on my graph, which means I would not have the equal to symbol here or here. But that is the only difference between the greater than or equal to and the greater than. It still would be an OR inequality. So let's generalize this. If we have some expression in absolute value, and that expression is greater than or equal to some real number a, that means that expression has to be either at a or larger, so shading to the right, or at -a or smaller, shading to the left. Which again leads us to an OR inequality, less than or equal to -a, or u would be greater than or equal to +a. Again, that word OR is written when you have that greater than or greater than symbol. A little note down below, so when we're writing our solution set, if we're writing our solution set as an inequality or using set builder notation, we have to use the word OR, but if we're writing interval notation, we'll use the union symbol to represent each of those intervals. All right, so in general, if we have an absolute value inequality using greater than or equal to, we're going to rewrite it as an OR inequality. We could use the graph to help us. Then we'll solve, and then we'll graph the solution set. So we'll look at two examples in this video. First one is absolute value of 3x plus 4 is greater than or equal to 2, which I have here. All right, so in general, if you are stuck on how to set up your inequalities or whether it's an and or an or, the graph will always help you. So I'm going to graph the meaning of this statement. So I'm looking at values that have an absolute value of 2, and that's either 2 or -2. Now, the absolute value of this expression is either equal to 2 or it's farther away from 0 than 2, or -2 is. So the graph of this expression would either live here at +2 or bigger. So either 3x plus 4 lives over here, or 3x plus 4 lives over here. These are the values that are further away from 0 than 2 units. All right, so I have two pieces, so I'll use that to write my OR statement. Either 3x plus 4 is less than or equal to -2, or 3x plus 4 is greater than or equal to positive 2. And I'm getting these right from my picture. Now that I have my compound inequality, I can solve. It's an OR, so I'll solve them separately. Subtract 4 on this side. 3x is less than or equal to negative 6. Divide by 3. X is less than or equal to negative 2. Or, let's go to the other inequality, also subtract 4. 3x is equal to negative 2. Divide by 3. And I have, not equal to, greater than or equal to. I have x is greater than or equal to negative 2/3. So this is my solution set. If I want to write my solution set as an interval, I might want to graph it first. It's helpful. Negative 2 is smaller than negative 2/3, so it's to the left. Now I want to be equal to negative 2, but less than that. So equal to negative 2, but less than that. And then greater than or equal to negative 2/3, so equal to and greater than, looks like that. So as an interval, I have two pieces. This one would be negative infinity, comma negative 2, parentheses around negative infinity, bracket around negative 2, union, bracket negative 2/3, comma infinity, and then parentheses. So that would be the interval that represents the solutions for x that make the original inequality true. Going to the second example, here we have absolute value of 2x minus 3 is greater than 5. Once again, I'm going to draw a graph of this inequality just to help me understand its meaning and help me set up my compound inequality. So the absolute value of this expression has to be more than 5 units from 0. All right, here's 0. Here's a number that's 5 units away. Here's another number that's 5 units away. I don't want to include those numbers, but I want to be farther from 0 than those two values. So I'm shading to the right of 5, but not including 5. I'm shading to the left of negative 5, but not including negative 5. And that's where 2x minus 3 lives. So I'll write my two inequalities. 2x minus 3 is less than, or not equal to, just less than, negative 5. Or 2x minus 3 is greater than positive 5. Right, so I'll solve those two inequalities. Add 3 to both sides. 2x is less than negative 2. Divide by 2. X is less than negative 1. Or, going to the other inequality, add 3 on both sides. 2x is greater than 8. Divide by 2. X is greater than 4. So this is my solution set. These are the values for x, which would make this inequality true. I can graph that. Here's negative 1, here's 4. I'm not including either of them. I'm less than negative 1, parentheses shading to the left. I'm greater than 4, parentheses shading to the right. As an interval, parentheses negative infinity, comma negative 1, parentheses, union, parentheses 4, comma infinity, parentheses. And again, this solution set tells me what values x can be to make this inequality true. In the next video, we'll talk about some funky things that can happen with absolute value inequalities.